Okay, this is lesson 4.3, all about congruent triangles. So we are going to start adding more theorems to our collection that we already have going, so that eventually here, and we're going to be doing it in this lesson, we can start writing proofs to prove two triangles are congruent. So we learned the last two in the last lesson, the triangle angle sum theorem and the exterior angle theorem. Now we have the third angles theorem for a triangle. Basically, it just says that we know all three angles of a triangle add up to 180. So if you know what two of the interior angles are, you can automatically figure out the third one, right? If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. It's not actually what I just said, but it's the same difference. So if we're trying to prove two triangles are congruent, and I know with these two, if I know B and S are congruent, and A and R are congruent, if these are the same measure and these are the same measure, automatically, because once I know two angles, the third one has to add up to 180. If these two angles are the same as these two, then the third angle, if I don't know it, has to be the same as this third angle automatically. So that's the third angle theorem. So let's look at numbers 1, 2, and 3, and we have to start kind of identifying congruent parts of triangles. So I'll zoom in a little bit here. Okay, so the directions say, I know you can't read them all. The directions say show that the polygons, which are triangles, are congruent by identifying all congruent corresponding parts. Then write a congruence statement. Okay, so triangles each have 3 sides and they each have 3 angles. So when we're talking about things being congruent between two triangles, we have to compare all 3 of the angles and all 3 of the sides. So that's 6 things total that we're saying are congruent. Excuse me. All right, so for here, first thing I'm going to do is start with the angles. You could start with the sides too, it doesn't matter. Angle A over here is marked with one little line. And angle J over here is marked with one little line. So these are corresponding angles. They're in the same position of the triangles, and they're congruent. So I'm going to say angle A is congruent to angle J. And if they're congruent, I know they're corresponding. Okay, then I'm going to move up to angle B. Angle B is marked the same as angle K, and they're in the same position. So I know angle B is congruent to angle K because they're marked congruent. Okay, so then without even looking automatically, I know those third angles have to be congruent because of the third angle theorem, but they're also marked congruent here. So angle C is congruent to angle L. So now I've talked about all 3 of my angles. Now I need to look at my sides, right? So I'm going to start with side AB. It's got this one little tick mark or hash mark there. Side JK also has one little hash mark. So these are corresponding and congruent. So AB is congruent to JK. And then BC here has 2 little tick marks. KL has 2 little tick marks. So BC is corresponding and congruent to KL. And then lastly, AC has 3 little tick marks on the bottom. JL has 3 little tick marks on the bottom. So AC is congruent to JL. So once I know that all 6 parts of the triangles are congruent to each other, I know that the triangles are congruent to each other. So now I can just say triangle ABC is congruent to triangle JKL. Now it seems like I'm just naming my 2 triangles and it doesn't matter how I name them, right? Well, it actually does matter how I name them. Whatever order you put the first triangle in, you have to put the second triangle in corresponding order. So since A and J are corresponding angles, if I wrote A first here, I have to write J first here. Since B and K are corresponding, if I wrote B second here, I have to write K second here. And C and L are corresponding, so I have to write them in the same position. So I could have called this angle BCA, right, BCA, but then I would have had to call this one triangle, not angle, triangle KLJ if this was BCA. whatever order letters I put the first triangle in, I have to put the second triangle name in corresponding order. Okay, number 2. Looks like a parallelogram, but I've got 2 triangles here, right? Excuse me. So I'm going to mark everything congruent. I'm going to start with my angles. Angle A here is marked congruent to angle D. Angle A, congruent to angle D. Second, I have this angle B, but I can't just call it angle B. Why? Because there's actually 2 angles here at angle B, so I have to be specific in which one I'm talking about. I'm talking about this left angle B, which is ABC. So angle ABC is congruent to this guy down here, but I can't just call it angle C. It's got 2 little marks just like this guy. I have to be more specific because is it this angle C or this one? I don't know. So I'm going to call this DCB. Angle DCB. Whatever the vertex is, that letter goes in the middle. So I'm talking about this little angle right here. Okay, so I've got angle A is congruent to D. This guy is congruent to this guy. So then the third angles have to be congruent, right? And I can't just say B and C are congruent. I have to be specific. So I'm going to call this DBC. DBC, and that's congruent to ACB. Okay, so that's my 3 angles. Now I have to talk about my sides, right? Excuse me. So I have to say AC down here with the 1 little hash mark. Side AC is corresponding and congruent to this top guy right here, side DB. Or BD. Doesn't really matter which way you call it. Then I've got this side here, AB, with the 2 hash marks. And it's congruent to this side down here that has 2 hash marks, right? DC. And then lastly, I've got this side. Now, it's side BC, and it's used in this triangle, and it's used in this triangle. So I'm going to mention it when it's used in the left triangle, and it's the same size as when it's used in the right triangle. Oops, sorry, didn't realize you couldn't see that. My fault. So I've got my sides, AC and DB, my sides AB and DC, and then I just wrote this guy right here. So this is the same size whether I'm using it in this triangle or whether I'm using it in this triangle. So I write BC is congruent to BC. I have to make that statement. I can't just not write it down. And it seems silly because it's only 1 line, but you have to say what it is used in the left triangle and what it is used in the right triangle. And now I've named all 3 angles and all 3 sides, so I can say that triangle ABC is congruent to triangle. Now, I named A first, and it's corresponding to D, so D goes first. I named this angle right here first, so now I've got to name this guy down here first, which is C. And then A, B, C, D, C, B. This B is congruent to this C, right? I had to name them in corresponding order. So this is my congruent statement. These are all the corresponding congruent parts. This is my congruency statement. Let's do one more. All right, this one's a little trickier, right? A little slightly trickier. None of the angles are marked congruent here, right? So we have to do that on our own. But what is marked congruent are the lines that are parallel. And it looks like I've got a transversal cutting through them, right? So I've got 2 sets of parallel lines here. I've got this guy and this guy are parallel, cut by that diagonal transversal line. And I've got the top and the bottom are parallel, cut by the transversal. All right, so first thing I'm going to do is go ahead and get the sides out of the way, right? So this side down here, JM, is corresponding and congruent to the top line here, KL or LK, doesn't matter which way you name it. And then this side over here is marked corresponding and congruent to this side. It's not marked corresponding, but it's marked congruent. So side KJ is congruent to side LM or ML, doesn't matter which way you say it. Okay, but that's only 2 sides of a triangle, right? What about this third side here? Well, it's just like this guy over here. just marked on it. This last problem where both triangles shared one side. Both triangles here, let's call this triangle 1 and this triangle 2, they both utilize side KM, right? So we're going to say KM, when it's used in this bottom triangle, is the same size as when KM is used in the top triangle. I still have to make the statement that this third side of this triangle is congruent to the third side of this triangle. I have to write it down. Okay, then lastly, we have to go over all of our angles. Okay, well, I don't know, right? Well, I'm going to go ahead and look at my two orange parallel lines and say that this angle is congruent to this guy. Now, I don't have to give a reason when I say they're congruent, but I know that they're congruent because these are alternate interior angles. They're made by parallel lines cut by a transversal. They're inside the two parallel lines on different sides of the transversal, so they're alternate interior. And when lines are parallel, alternate interior angles are congruent. So I'm going to be specific. I can't call this angle K because there's another one here. So I'm going to say JKM, angle JKM, is congruent to angle LMK. Okay, so that's this angle and this angle. Okay, I also know it works the other way, right? When I'm talking about this yellow line and this yellow line cut by this transversal, I can say that this angle is the same size as this angle because they're alternate interior. So angle LKM is congruent to JMK. So I know these two angles are congruent and these two angles are congruent because they're all alternate interior, but I don't know about J and L. Excuse me. But I just learned the third angles theorem that said once I know that two angles of a triangle are congruent to two angles of another triangle, I automatically know that third angle has to be congruent. So I'm going to say angle J is congruent to angle L. And I don't have to give a reason here, but I know it's because of the third angles theorem. And now I've named all three sides and all three angles, so I can go ahead and make my congruency statement, which is that triangle KJM is congruent to triangle. Now I have to be careful of the order of the letters, right? J and L are congruent, so I know L is going to have to be the middle letter here. So I have K, J, M. I'm going to start, I started up here with this one guy, so I got to start here. So I'm going to say M, L, K. M, L, K. There's my congruency statement. Triangle KJM is congruent to triangle MLK. K and M are congruent. This guy and this guy are congruent. J and L are congruent. I didn't mark it. 1, 2, 3. 1, 2, 3. And M and K, this M down here and this K up here are congruent. Oops, sorry. This guy here is congruent to this guy. This guy is congruent to this guy. J is congruent to L. They're all marked congruent. They're in the correct order. So this is my congruency statement. Okay, so now I can use what we just learned. Let me back up a little bit to kind of solve for something mathematically. So here, for numbers 7 and 8, they're over here on the left, but I'll show you the picture. It says to solve for x and y. Number 7 says solve for x. Okay, so where do I see an x? I see an x here. Uh-oh, but I can't solve for it until I know what y is because there's a y in the problem. So first I want to solve for y. Okay, fine. So I see that angle D here is 2y minus 5 degrees. That's the only place I see a y. So I got to figure out what's the corresponding angle to D over here. Well, in the directions for number 7 and 8, it tells me right here, triangle ABC is congruent to triangle DEF. I know what angle D is. I want to find the corresponding angle on the other triangle. So since D is the first letter here, the corresponding angle is going to be A because it's the first letter here. And A is this, oops, this guy right here. So since A and D are corresponding and the two triangles are congruent, that means the corresponding angles are congruent. So I can just set these equal to each other to solve for y. So 2y minus 5 equals 65. And again, it tells me up here that the triangle is congruent to the other triangle. That means everything about them is congruent. I like my Paw Patrol Band-Aid. Courtesy of my son. Okay, so here I'm going to solve for y. I'm going to add 5 to both sides of my equal sign. 2y equals 70. And then I'm going to divide both sides by 2. Y equals 35. So there's my y. Once I know y, I can solve for x, right? Well, I said here, x is over here on this side. So I need to find the corresponding side to EF. So I don't know if it's BC or if it's AC. I'm not really sure. So EF. Where is EF in this triangle name? It's the second two letters, right? Right here. So the corresponding side would be the second two letters here, BC. So BC is corresponding to EF. This side is corresponding. So I can set this equal to this and solve because they're corresponding, so they're congruent. 2x plus y equals 90.6. 2x plus y equals 90.6. And I just learned down here that y equals 35. So 2x plus 35 equals 90.6. Now I can start solving. I'm going to subtract 35 from both sides of my equal sign. So that leaves me with 55.6. 2x equals 55.6. And then I need to divide both sides by 2. So x is going to equal 27.8. And it's okay if you get a decimal. That's okay. It just happened, so it's perfectly fine. Let me know if you have questions.